Hi. So in this video, I wanted to talk about Unity's new input system. Technically, it's not new. They introduced this in like 2019, but this is the input system. Within Unity itself, they have an old input system and a new input system. I'm just referring to that quote-unquote new one. So to start, this is the official page for it, and you can find this on your Blackboard. I do think it's worth reading. This is a whole page for it. There's a bunch of links in here, and it kind of expresses how to use it and what the philosophy behind this input system is. This is going to be kind of a foundation for us because we are going to start by learning this input system, how it's used, go through a small example now. And this is going to set us up perfectly to start building our third-person player, because obviously one of the fundamentals of our player controller is going to be receiving inputs, and we will be using this new input system. So to start, let's just kind of talk about the idea of this new input system. So traditionally, before these new input systems, and when I talk about these input systems, just know that if you've used Unreal, Unreal also has an old and a new input system, with the new one being similar to Unity's new one. And this is just kind of the more modern way of doing things. And the big reason that we have this more modern way of doing input systems is for modularity, flexibility. And again, we'll see how that works. So the idea of inputs is broken up into three kind of basic concepts. So we start with the user on one end. So this is, us as a player. And then we have an input. I apologize for the handwriting. And this could be something like our keyboard or a mouse or even our controller. So the user presses an input. These inputs are fed into what is known as an input context. We will just take a look at the context next. And these contexts contain a bunch of actions. And finally, the actions contain, again, I don't want to reuse the word input, but the action contains buttons. B-U-T-T-O. Buttons. So actions can be anything like an action our player can take. They're not going to be specifically WSAD or spacebar, but they'll be the overall action. So for example, an action can be something like move, jump, sprint. These are some of the actions we're going to look at. And these actions are going to be bound to certain buttons. So WSAD for move, but also maybe the left analog stick of a controller. Jump could be spacebar. Or, it could be the A button. If you're using an Xbox controller, the cross button on a PlayStation controller, the B button on a Nintendo controller, that bottom button. Could be any of those. And I don't know, sprint usually on keyboards is the shift key. Or we could use it, I'll just call it L3, but when we press down on the left stick, that's like a usual control for sprint. But the nice thing about this is we've separated our actions from our buttons. And this lets us, again, kind of program in all the different types of inputs we can have into the actions. And this also leads it so that our users can customize these controls, because they just change the button that relates to the action, and our code will only be working with this action. Finally, just to get onto input contexts, we take a set of inputs, for example, and those go into a certain context. So, for example, move, jump, and sprint could be our player's land controls. Land actions. Maybe there's a different set of actions for when they're driving. We won't be using move anymore in driving. For driving, we might have things like accelerate, brake, And those could also turn as well. And those could also, relate to certain buttons. So maybe accelerate is space, brake is shift, and turning is using the A and D keys. So again, the buttons are the same, the context changes, and the context gives us the bunch of actions. And really the reason we do this is so that we can have one player controller and we could change the context depending on what they're doing. And this is a good example. If you think of a game like Fortnite, for example, I know that's made in Unreal, but Fortnite, for example, has our player starts off, they're in the battle bus. That input context while they're in the bus is totally different because you just hit the A button, you jump out of the battle bus. There's no moving, jumping, sprinting. When they're on the ground, they can move, jump, sprint, aim, shoot. However, we can get into vehicles where our controls change. When you're in building mode, the controls change a certain amount. And so all we do is swap the current active context. What is the context? Are we on land? Are we driving? Are we swimming? And of course, it's different for every game. Even flying, it's a different type of context. But this lets us, again, make our inputs a little more modular. So the whole reason we have this new type of input system is one of the big focuses on games, especially AAA games, is accessibility. We want as many people to be able to play our game as possible. And a big way to do that is to have customizable controls, not just customizable controls, but if a player is using something that's not an Xbox controller, not a PlayStation controller, they're using some third-party controller, maybe they're using an accessibility controller, we need to be able to map these buttons to different things and still have them be usable. And this new input system that both, again, Unity, Unreal, both use, lets us do that with ease. So us as developers, we don't have to put much effort into having different, into programming our own inputs that are super customizable. The engines are now giving it to us, and we just make a UI for that to work with. In this class, we're not going to go over like actual customizing of buttons. We're not going to be building a UI for that, but we will be using the new input system. And, before we used to do this traditionally, all we would do in our code is we would just check for if WSAD is being pressed. We would check if spacebar is being pressed. And you can imagine how that would kind of make our code just very large and like almost at some point, if we're incorporating every controller type into it, it's just going to require us to go in and be like, are we pressing space or A or X or B? Okay, then jump. Instead, now we can just be like, okay, is the jump action performed? Then jump. We can read the move action, for example, being like, what is the move action? And we can move our character according to that. So, okay, that's enough of like kind of a preamble. Let's go take a look at this working. So to start, and this should be installed for everyone, but let's just make sure. Just for context, all I've done here is I have made a new Unity project with the name Game 236. Although it should be 326, that's a mistake, whatever. So I made it with the title of this class. And so it's a brand new project. In the package manager, we just need to make sure that the input system is installed. So I went into the package manager in my project, that's the current tab selected, and input system is here. It's letting me update it. I don't need to do that specifically right now, but we just need to make sure that it is here. It should just be installed by default. I believe most projects, that you start with the newer versions of Unity, it's installed, but just worth checking. And if it is installed, if it isn't installed, go ahead and install it. You'll find it under the Unity registry here. You can just search for it as input system, and you'll find it here. And go ahead and install it if it's already not installed. And then go to Edit, Project Settings. We need to actually tell Unity which input system we want to use, old or new. And under Player, if we just scroll down a little bit, you'll find Active Input Handling as an option, and it should say Input System Package in parentheses New. If I click it, you can see there's Input Manager. This is the old one, or we can use both. Let's just stick to the new one. There's no reason to use the old one. One of the benefits that you can still garner from actually using the old input system is just it's a little quicker to use. There's not much setup involved. So it's great for prototyping. But I would suggest we just use the new input system even when we're prototyping. It's just like a one-time setup and then we're done with it. So, we don't have to switch it later on. We already have it there. So with everything installed, let's take a look at how we can work with this. So to start, I am going to make a folder, just like I did with the last project, and call it scripts. Now the first thing we need to create is what's known as an input action asset. This action asset is going to contain these input contexts and these actions and these buttons. So it's going to contain all of these. All of these together make up one input action asset. So we right click, create, and all the way at the bottom there's input actions. And this creates an input action asset. I'm going to name this player input. We can double click it. That opens up a little editor here where we can see what we were talking about, actions or action maps, and there's actions, right? So these action maps are what I was calling contexts. We can have multiple different types, right? But our game, we're just going to have our player running around jumping. We don't need multiple action maps. You might want to if you're going to have different modes in your game. But for our purposes, we only need one action map. So I'm going to click plus to add one, and I'm just going to call it player action map. Again, don't forget to follow some kind of convention when you do this. You would notice that my player input starts with a capital P. My player action maps start with a capital P, and I'm going to make my actions also start with capital letters, just so that I remember it. And when I need to search for these things using strings in my code, I know the exact name. So let's start by adding 3 actions. I can hit this little plus button all the way to the left of actions, and you'll see it add a new action 1, 2, and 3. And let's name these correctly. So double click on one of them. I'm going to call one move, one of them jump, and the other one sprint. So with an action selected, if we again look to the left-hand side, the right-hand side where it says action properties, you'll see that there's an action type. There's button or value or pass-through. Button is just an on or an off. So for sprinting and jumping, that makes sense, right? It's just going to be a button press. Either we can press the jump button or we don't press the jump button. Same thing with sprint. Either we press it or we don't. It's a button. You can click it. It's either on or off. Movement, on the other hand, is a little different, right? It's an axis. We move on the, if you think of a left stick of a controller, it has an up-down axis and a left-right axis, so an X and a Y axis. And together that makes up one move axis, right? That X and Y together, because we can move at a diagonal where we're using both the X and the Y a little. We could move straight forward where it's just the Y axis. So movement is an axis type. And so instead of a button, I'll change it to value. And then it asks us, what type of value is this? And there are a bunch of different types here. I'm going to use vector2. Again, that's to define those 2 axes, right? A vector2 will have an x-axis and a y-axis. So let's use that. And so that's us setting up our actions. The last thing we do, again, if we look at this diagram here, actions have buttons associated with them. So now we need to actually associate some buttons with these actions. And so there's to the left of the name, there's a little up toggle arrow here, and you can see there's no binding when I click on it. Same thing with jump, no binding. Same thing with sprint, no binding. So we can add bindings to it. We click on this no binding here. This is just a default binding that kind of shows up. We can click on it, and where it says binding path, this is where we select what we want this button to be. I can drop this down. You can see there's a bunch of different types of inputs here. There's gamepads, joysticks, a mouse, a pen. There's different types of sensors, a keyboard, and many different types of things. So I could select keyboard, and we could find the key here, just by going into by key location. And I know the space key is what I want for jumping, and I select it, and it says space keyboard. I could, if I also wanted to add the controller, for example, click this little plus button, add a new binding, and then here I would go into gamepad button south, because south is the bottom button. And there you go. This jump key now is associated with 2 things. If I had a gamepad connected and I hit the south key, it would register jump. If I hit the spacebar key, it would register jump. Very convenient. Again, we've added 2 different types of controls to one action. without much effort, really. Like now our code doesn't have to bother if we're using a keyboard or a gamepad. Our code doesn't need to discriminate. It just kind of does its thing. Same thing with sprint. I want to add the shift key. So in this binding, I can go here. I could click on keyboard, find shift, and do it that way. Or you can click this listen button here. And if you just hit the shift key now, it pops up any of those corresponding actions. So there's shift or there's left shift. I do actually want it to be specifically left shift. I don't want right shift to sprint. The same thing is true with the controller as well. So for example, the sprint key, I could click this plus, add a binding. Under path, now I have a controller connected. If I do listen and I just click the left stick in, you can see there you go. Left stick press gamepad, that's a generic gamepad, or left stick press on an Xbox controller. That's just when we connect a gamepad that's not an Xbox compatible controller to your computer, it just reads it differently, a different driver. So it's just, telling us that it could be either or. So I'll say left stick press on an Xbox controller because that is what I'm using. So that's how we map buttons, super simple. Now, moving on to the movement axis. So unlike our bindings of our buttons, this is going to be an axis, right? So a single button doesn't make up an axis. But if we think about the keyboard controls, W, S, A, D, W would be positive on the y-axis, positive on the up. Pressing W is the same as moving the left stick up. Pressing S is the same as moving the left stick down. Pressing A is the same as moving the left stick to the left. And pressing D is the same as moving the left stick to the right. So it's like these buttons, W, S, A, D, they don't just represent button presses. Instead, they represent us moving in a certain axis. And so we need to actually build that up. But we'll start with the low-hanging fruit. Let's bind my left stick to this. Very easy. Same way we did the other ones. I'm just going to hit listen, move the left stick in any direction, and you can see left stick. That is just the axis. We can't quite do the same thing for WSAD. Instead, when we hit this plus to create a new binding, we will see the second option here. It says add up, down, left, right composite. So a composite is just taking those separate inputs and turning it into one thing. It's composing it. So we'll click that. It adds another 2D vector in here. If I drop this one down, now we have 4 different bindings, one for up, down, left, and right. And this is where, just like I did before, I could do W, I could do S, I could do S, I could do A, and I could do D. So there you go. I have my basic controls set up now. Very simple. We've set it up for move, jump, and sprint, which let's take a look at how we use those now. And also, again, remember, we have set these up not just for keyboard, but also for controller. So that makes it very simple that, it's just working, that we have all this set up without too much effort. We haven't written any code, really. We've just set up the controls. After that, we're going to save the asset. And let's close out of this. So to start, I am just going to set up a small little scene here. I'm going to set up a plane. And I'm going to make an empty game object, called it player. And to this game object, I'm going to add a capsule. So this capsule is a child of the player. I'm going to move it a little bit up. And I just want to resize the capsule ever so slightly. So it's a little bit thinner, maybe a little bit shorter too. There you go. So this kind of just represents our player for now. Okay, I'm going to make a new script. And I will just call this, for now, let me call it input manager. So it's going to manage our inputs. Once it's all done loading, let's just trust it. So what our goal is here, just to start, what we need to do is we need to get a reference. So we need to make a variable and first get a reference to this input context. This input context, first we need to get a reference to the whole action asset. then get a reference to the input context, which is going to contain references to these actions, and then we can use these input actions and read the values from them. So for example, this jump action, it's going to be outputting, either a true or a false, or a 0 or a 1. And this move action is going to be outputting a vector 2 in the form of, either 0, 0. Maybe if we're pressing the W key, it'll be 1, 0. It's going to be outputting a value like that. And so we need to read that. So the first step is to get a reference to the whole action asset as a whole. And we can do that by just making a global variable here of type input action asset, just like what I said its name was. And I'm just going to call this action asset. So we do want to somehow link a reference to this. The easiest way to do that is through a serialized field. Let's just take a look at doing that real quick. So down here, I am going to add the input manager to my player. There it is. And you can see action asset is asking for 1. You could click on this little circle here that'll show the input actions here. This input system is Unity's just kind of default one. And this player input's the one I made. So I could double click that and add it, or you could just go ahead and drag it in there. Whatever's more convenient, both work the exact same. So now we have a reference to this input action asset. And we need to make use of it. So first, from the action asset, we need to get the context, or that action map, right? So we'll make a private action. It's called a input action map. And I'm going to call this action map. And this input action map is going to contain 3 actions. That's what mine contains, right? So I can make it. Now we can get an input action. I'll call it move action, jump action, and finally sprint action. And when we start the game, first thing we want to do is we want to set the input action map. And so we can do that using a function within the input action asset called find action map. And this is where we need to pass a string that is the exact name of our action map. So if I go back in my player input, I have called my action map that I want to use player action map, starting with a capital P. And so here I need to type that exactly the same. Player action map. Now an easier way of doing this, just rather if you're struggling with the spellings, is to go back in here. We can just double click this to rename it, Control C to copy it, and then we could paste it there. That's just an easier way. If you want to just be sure we got the spelling correctly. So we need to set our action map equals this action map that we find. And then next we need to get the actions from the action map. One good thing here is to do what's called a sanity check. So if sometimes, for some reason or the other, this action map might not set correctly, and we don't want to just continue the rest of the code without being notified that this action map doesn't exist, so we know something has gone wrong. So we can do that just by checking, if the action map is equal to null, so if it's empty, because it starts off as empty and then we're setting it, so if it doesn't set correctly, it's still going to be empty. We can debug.log error, so we can log an error that says action map not set correctly. And this could be for a variety of reasons. Maybe we didn't spell it correctly, right? So it wouldn't have set correctly. This is just going to help us know that is where our error is coming from. And if all good, let's set our action. So move action is going to equal to, so just like the action asset had a find action map, the action map is going to have a find action. And this is going to do the exact same thing. It's going to take a string of that exact name. So I know move action was called move. I know jump action was called jump. And I know sprint action was called sprint. And there you go. So we have gotten access to these, and now we just need to use them. So we can see that really easily. One of the easiest ways of using these action maps is to just like check it in the update, and we can print something based on that. So let's check the jump action to start. The buttons, being on or off, we can use it as a Boolean because it's going to be a 0 or 1 or true or false. So let's make a bool called jumped, and we can set that to jump action dot is pressed. So there's a function inside jump action called is pressed. If it is pressed, it's going to return true. If it's not pressed, it's going to return false. And again, we can see this by doing debug.log. Jump action equals jumped. So let's take a look at this. Go into our console. Let's just collapse it so everything is all set. Hit play. And currently I'm not pressing spacebar. You can see jump action equals false. If we just look at this right-hand side, we can see how it's increasing in number. And I'm going to hold the spacebar. And okay, when I hold the spacebar, you can see that it works. Now, sometimes for some reason this might not work initially, and one thing we need to do is to enable the action map if it's not working by default. And so just in start, as soon as I find the action map, I'm just going to do action map.enable. There's a function inside action map called enable, so we need to enable it. And there you go. That was as easy as that. It was a little more roundabout than just checking an update if we press the spacebar. Where now, we're using the jump action. But it's kind of the same thing, right? We're just checking if jump is pressed, and we're just debug logging that. So you can think about, in pseudocode, it would be like if jump is pressed, we would be like, if we jumped, then you just run the player's jump command, right? So that's the same as doing if spacebar is pressed, jump, but now we're doing if jumped, instead of it eventually being something like if spacebar or A or X or B or whatever was pressed, jump. In the same vein, let us just take a look at reading the 2D vector. So the same thing would apply for sprint, right? Instead of bool jumped, I'd do bool sprint. Sprint action is pressed. The movement input's going to be a little different because it's going to be a vector. So let's same thing. Let's just take a look how to read it. So I'm just going to make a global variable here and call it's going to be of type vector2, and I'm going to call it move input. And all I'm going to do in update is I'm going to set move input to equal my move action. Dot instead of is pressed, we're going to use a different function called read value, where inside these angle brackets we tell it what the type of value is. So I set my value to vector2. And so that's what I'm going to read. Again, the type of value that we're setting is the exact same that we have used inside this player input. So move is of type vector2. That's the control type. And so that's all I've typed in here. It's a vector2. Move input's also a vector2. So they're all going to fit together nicely, and we'll be able to store it there. And just like I did before, I'm going to debug.log move input equals move input. And so with that saved, let's take a look if it works. And here we can see movement equals 0, 0. I'm not pressing anything. If I hold the W key, it equals 0, 1. We're moving forward on the y-axis, or W is up and down technically, so it's on the y-axis. S would be -1. A would be -1 on the x-axis, and D would be +1 on the x-axis. Same way, if I hold W and D, you can see it's 0.7, 0.7. This is just kind of because of how a circle works. It's not going to be 1, 1. Either way, you can see that I can like mix the inputs and put them in together. And it's just reading that value. So the same way, you know, we would just read this movement input, and then we can move our player along that direction. The last thing I wanted to enter this video with is right now, if we were to do this, and this isn't bad, you know, this way we still get the benefits of using the input actions where our users can customize their controls. But you can imagine that if we had a lot of controls, then this update function is just going to start to get clogged. It's going to be like, okay, what is jump? What is sprint? What is move? What is crouch? It's going to be checking each one by one, right? So instead, and we'll take a look at this concept in the next video as well, we can use something known as Unity events, and these input actions actually output events, and we can actually use these events directly and bind functions to them. So let's take a look at how that works. It should be a little more, make more sense after that. So instead of doing anything in update, what I'm going to do is I can do move action, and there is a function within move action called perform. This isn't a function, it's technically something called a delegate. And I can add a function to this delegate. So I could say move action, when this performed happens, I want to run a function I'm going to make called onMove. And it's the same thing for move action.canceled. So performed happens when the button is pressed. Cancelled happens when the button is released. It's as simple as that. So when I press down, you know, if I move the left stick, performed is going to be called. When I let go of the left stick, cancel is going to be called. And for me, either way, I wanted to run my onMove function. So let me make that onMove function. So void onMove. And you can see I'm still getting an error here. And this error specifically says no overload for onMove that matches the delegate action. Input action callback context. So what this is really saying is when this performed happens and it tries to call my function, it wants to pass on a parameter that is of type input action dot callback context. And so I need to actually have a parameter for that. So I can do that just as the name said in the error, input action dot callback context, and I'll call this context. This context is the exact same as this move action here. So just like we did move action.read value, we would do context.read value. The same way, we could call it of type vector2. And same way, I could set my move input to it. And the exact same as we did in update, I can debug.log move input equals move input. And so this is going to do pretty much the exact same thing. I had spelled this wrong here. When the move action is performed, it's going to call this onMove with whatever we did. So you can imagine if I hold the W key, it's going to call onMove, pass this move action as its context. We're going to read the value, which is going to be 1 in the y-axis. And so we're going to debug.log that exact same thing, 0, 1. When we let go of the W key, it's going to call the canceled function, pass it along as a context. We're going to print out 0, 0. So let's just take a look at that in action again. And we can see right now I'm not pressing anything and nothing is being printed out. Before it was printing out 0, 0 over and over again. But now when I press W, it prints out 1, and you can see it's only printing it out once. It's not constantly printing out. When I let go, it's going to print out 0, 0 just once. Same thing with any button. It's not going to be constantly trying to read the value. Instead, it's only going to read it when we press a button. So only at the time of pressing a button are we actually running this code. And this is great for two reasons. One, we're not clogging up this update function. This is its own separate function. It's just doing its own thing. And two, it's not going to be as inefficient, right? We're not constantly reading the value. So when we're not pressing anything, we're not running that code that's constantly reading the value. It's only happening when we press a button, which makes it much more efficient. We can do the exact same thing with a jump action, the same way we have done with the on move. You know, we could make an on jump with an input action dot callback context, and then we'd do the same thing. We'd say, like, if that context dot is pressed, do something. And this, again, just helps us separate our code out and makes it slightly more efficient, but also much more readable, because rather than having all this in update, they're going to be its own functions. If you want an extra little reading on this in the same book that we're reading for class, just read the chapter on the observation pattern. That is kind of what this is based off of. Again, we'll take a little look at that in the next video, where we talk about Unity's event system. That's another part of something we're going to use, and that's going to help solidify these understandings. Anyway, that's just been a short video on the new input system in Unity and how we're going to use it. Thank you guys for watching.